Okay, how you doing? We're going to talk about how it is that you find a slope of a line from a graph. We've already talked about in my other videos. I've talked about how it is that you find slope from a equation. Or through given two coordinate points. I'm sorry, not an equation. So now I'm just going to talk about how does that relate to this idea. Okay, so if something is linear, its rate of change is constantly going to be the same, and slope is a rate of change. So therefore, I need to figure out what is the rate of change from coordinate to coordinate. And it doesn't matter what coordinate I choose, and I'm going to show you that in a second. But the ratio from whichever coordinate pair you choose to the next coordinate pair that you choose must always come out to be the same. I have a line here. So I am just going to automatically presume that this is a linear function because it is a straight line. So what I want to show is how do I find the slope. So the slope is found basically saying what is your change in y divided by your change in x. Well, all that is finding is literally how does my vertical change divided by my horizontal change, and how is that affected? So there's a couple of ways you can look at this, and I'm going to show you two at this point. So the two that I'm going to show you is one thing that we can utilize is something called a slope triangle. And the slope triangle is no other than taking a look at this and connecting 2 points on your graph by using a triangle. So what I'm going to do is I'm going to connect this point here and this point here. So here we go, connecting my points. So there's my points. Sorry. So there's my points with a slope triangle. Note for a second that I did skip a point, which is okay. I'll come back to how that's okay. So all I now have to do is I either have to start at one point and follow along the line and use my direction on how do I get to one point. But I cannot start at one point, go up, and start at the other point and going. Once I start from one point, I must follow along my triangle until I get to the other point. Because signs are going to play an important role into this one. So it doesn't matter which point you choose, and I'll show you why, because the ratio is going to be the same. But it does matter that once you start, you must continue to follow until you get to the other point. So I'm going to start down here at this point. And all we're going to do is talk about what is the length of this line. Well, if you're on a graph, it's very simple. You just start counting how many places you have to go up. So here's 1, 2, 3, 4. So I've started here and I've gone up. Well, the upward motion on a graph is associated with a positive value. So this is a +4. Now remember, okay, once I get +4 and once I start counting, I must follow until I get to the other point. So I'm going to start here. Now I'm going to go 1, 2, 3, 4, 5, 6. So since I go to the right in my movement, it is now considered to be plus, because along the x-axis, anytime you move to the right is considered to be a positive movement. So now I have literally 4 and I've got +6. So what I now need to remember is that slope is always the ratio of your change in your y coordinates, which on a graph like this is up and down, divided by your change in your x, which the x's is left and right. So all I have to do now is take 4 and divide it by 6. And slope always needs to be written in simplest form. So I have a fraction, so my ratio here is 4/6, needs to be simplified to being 2/3. So my slope, which I'm going to represent with the m variable, is equivalent to 4/6, which is simplified to being 2/3. Now, what I do want to point out here is I'm going to draw another slope triangle in, is that it does not matter what points you choose. So here we go. I'm going to draw another slope triangle, and instead I'm going to go from this point directly to that point. Okay? So if you notice, I drew another slope triangle in. So again, it doesn't matter which point you start from, but once you start, you must continue to move along that pattern. So instead of starting down at this point, I'm going to start up here. So I'm going to move, so I go 1, 2. So this, I've started and I've gone down. Well, down is a negative movement. So this now becomes a -2, okay? So that is -2 from here to here, but remember, once I start, I must keep going so I get to the next point. So I start off by going, so I'm here, I go 1, 2, 3. So this now here is -3. So in this slope triangle, I now take a look at it, and it must be, okay, 2/3, because I've already used 2 points and decided that it was 2/3. So I have a -2 and a -3 here. So if I continue on with this particular idea here, okay, I'm going to get, again, it's the change in y divided by the change in x, which is negative 2 divided by negative 3, which a negative divided by a negative, okay, my slope here, is still equivalent to 2/3. So, things I want to point out here. It doesn't matter which point you go from to the next point. It doesn't matter really if you start by going down or going up, but once you start your movement, you must continue until the other line. And you must mark off the direction of your movement by either positive or negative. So remember, if you move to the right, it's positive. Move to the left, it's negative. You move up, it's positive. You move down, it's negative. So those are some things you have to remember. And the other thing that I do want to point out here is it doesn't matter which point, because the ratio of the rate of your change is always going to be the same. What you need to note is that this is constantly moving in a smooth line up. Okay? So, the other thing we want to make a note of is just to check that our answer is correct, is that as I read this graph from left to right, meaning I put my finger on a point to the left and I move to the right, please note that when I get to another point here, okay, I find that it has gone up. So this point is higher than this, so from left to right my points are getting higher, and anything associated with being higher is positive, therefore that's why this is a positive slope. So I hope that helps, and that's how you read slope from a graph.